This example is going to work through page 610, an example of drawing Mohr's circle using the rules that are developed on 6-9. Got those rules summarized. Those steps or rules are to establish your axes, where your normal stress is horizontal and your shear stress is vertical, with the important distinction that positive shear, positive tau is down. We then plunk 2 points down on our axes. The first point is our normal stress in the x direction from our arbitrary stress state and our shear. The second point is the stress in the y direction and minus shear, connecting the points with a line, drawing a circle, and then the first principal stress, sigma A, is the right side intersection of the circle and the normal stress or horizontal axis, and sigma B is the left side intersection of the circle and the normal stress axis. So over here on the right hand side of the screen we have a Mohr circle example using the stress state that we've looked at previously. Now what that arbitrary stress state looks like, if I draw, is that we have a tensile sigma x, a compressive sigma y, and a positive shear stress. So that's the picture of the arbitrary stress state. And now we'll put this information on Mohr's circle. We have our, like a cooking show, we have our axes already pre-prepared for our convenience. So we know that this is our positive normal stress axis. We know that this is the positive shear stress is down, and we need to put our first point. And we'll go for red for our stress points. We have a plus 8,000 sigma x. So we'll call each of these divisions 2,000, 4,000, 6,000, 8,000. And we need the shear stress of 6,000, so 2,000, 4,000, 6,000. So our first point goes right here. Our second point is sigma y, stress in the y direction, is minus 3,000. So here's 2, 3 is halfway, so this is our minus 3,000. We have the same shear stress in the y, so we have 2, 4, 6,000. Here is our second point. So keeping track of how we've gone, we've got our axes, we've got our points plotted. Now what do we do? We're at step 3, connect the points with a line. And I'm going to try and cheat and connect these points with a line. Now, the important thing about this line, and I'm going to go for purple for this, is this intersection with the horizontal axis is an important quantity, and we call that the average normal stress. Okay? So now back over here on this side, we can check off our step 3. Our step 4 is drawing a circle that's centered at sigma average that passes through points 1 and 2. Okay, I'm going to come back over here, and again I'm going to kind of cheat and I need this to have no fill so I can see what I'm doing, and scoot it down so that There we go. So now we have a circle that basically passes through our points. And we can come back over to our checklist. And now what do we know? We know now that the right side intersection of the circle and the sigma axis is our sigma A. So this guy is sigma A, which is known as your first principal stress, and this guy over here, where the circle intersects with the normal stress axis on the left side, is your second principal stress. And we can figure out from geometry what these values are. So back over here on this side, we know that our sigma average is the two normal stresses divided by 2. So that guy is 8,000 plus a minus 3,000 divided by 2. So that average value is 2,500 psi. And if we come over here and look, even with my marginal art skills, we see that that guy is pretty close to being 2,500 on our drawing. Alright, what else do we get out of Mohr's circle? We know that the radius of this circle is an important quantity, and it is the half of the difference squared and the shear stress squared, the square root of the sum of those. So we have 8,000 minus a minus 3,000, half of that squared, plus 6,000 squared. So our radius is 8139 psi. And if we come here and count and look, we've got about 4 of our axis divisions, so that's a reasonable graphical representation as well. And then what do we know about our principal stresses? We know that our principal stress is this average stress plus the radius of the circle, so that's going to be 10,640. So we know that this value is 10,640, and we know that our second principal stress is the average stress, the center of the circle, minus the radius, and that one's going to be minus 5,640. So if we come here from 2,500 and we go negative 8139, we end up at our sigma B value, which is minus 5,640 psi. And now here's an important distinction. We can figure out these angles on Mohr's circle as well. Excuse me. The difference is when we translate this onto these axes, important to remember, the transformation angle theta is actually times 2 on Mohr's circle. So we have to think about this in terms of a 2 theta A is this inverse tangent of the shear stress over the difference term, is 47.49, and these are the same values from the example that we've already worked, that theta A is the 23.75. So if we come over here on our Mohr's circle, and I'll go for red for this, whoops, this angle right in here is actually 2 times the angle from the transformation matrix. And so on the Mohr's circle, this angle is about 50 degrees, whereas the theta in the transformation matrix is half of that, or about 24.